Hey everybody, welcome back. Let's round out this discussion now with Rust. So to just set some history, if you're coming in late, we started with service-oriented architectures. We talked about this entire paradigm of the service-oriented culture, where we basically have something that is publicly accessible to anybody, right? We touched on SOAP, which is one way of enabling this, and now we're going to talk about REST. And this is probably a term that you would have heard of even before this class, or at least I hope you would have, but this is a term that you should all hopefully be familiar with already, right? Because we have done Rails, we have done Flask, and those are both natively RESTful in and of themselves. So the idea with REST is that everything is going to be an HTTP command. So anytime you have a URL slug, which is basically, if we were to take here, I've got my Google Docs, so docs.google.com. If this were a RESTful call, so here's my domain, slash presentation could be the first bit for routing that. Then slash D could be display, hopefully. And then here we would have, a unique ID or something of that nature, plus edit, so that we can update things, right? So this would be a unique, easily identifiable URL slug. So the idea with REST then is it's all kind of based around this idea of HTTP. Now everything in REST is a resource. So it's a resource-oriented architecture. You get this in quotes. Now, where, I'm saying that you should remember this, when we talked Rails, we had those verbs, right? So whenever we had an HTTP operation like get, update, put, post, all of those fun ones, right? And we likened them to Rails verbs, that's exactly the same thing here. So I've got a view here of the getting started page, which hopefully doesn't incur too many horrific, nightmarish flashbacks to the beginning of the semester. But here we have our HTTP verbs, right? So get, post, delete, and then we have a pattern and some action. So here we are routing our user to different aspects of our site. We are making RESTful calls here. We are basing it around this HTTP verb. One thing with REST, though, where it differs from SOAP is that it's not a formal specification. Now, there are some guidelines for it, but effectively it's following the HTTP spec. It doesn't have its own RESTful spec. Now, there is a suggested one, right? So here, it's basically a work in progress type of a thing, but it's not formalized yet. So what are the goals of REST then? Well, we want to maximize independence. We want to maximize scalability. So those are two really good concerns to consider, right? Every single service should be completely independent from another one. We're not having any dependencies on the underlying system. We're not depending on UDDI or WSDL or anything like that. It's a self-contained unit. And with that, we're trying to minimize latency and communication. And that's kind of inherently native to being based around the HTTP concept. So to kind of give you a little bit of a difference here, REST versus SOAP, and we'll come back to this again in a little bit. REST is typically described as a postcard. SOAP is typically described as an envelope. I said SOAP envelope earlier as well, right? But everything in a SOAP message is self-contained. Everything in a REST call is it's basically we don't really need to specify the protocol. We don't need to specify a whole lot of extra things that we would in SOAP because all we care about is the content of this message. We are basing it around HTTP. And if you want the historical perspective, REST was actually part of a PhD dissertation a while back, and uh, it kind of started from there. And honestly, a lot of current technologies are based around various PhD research. So, in terms of RESTful calls and the web and all that fun stuff, REST gives us a very low barrier of entry, which is absolutely great. I've asked you twice now in homework and on an exam, how easy is it to update the web? And some people have changed their answer, get same, different. It's actually harder, it's easier, right? Different ways to look at it. But the idea with this is that the more we remove barriers of entry, so we don't need to know this big SOAP protocol. We don't need an underlying middleware. We don't need this. We don't need that. We're just going to use HTTP. That makes it so much easier for these services to work together and to communicate with each other. And since we're kind of relying on the underlying HTTP protocol, we can follow that development as we go and ideally, kind of grow with the web. So here as well, things are extensible. If things change with HTTP or with the various verbs and all that, it's pretty easy to update our RESTful services as well. With a RESTful service, we can have more than one deployment of a service. So if I've got version 1 here and version 2 here and version 3 over there, they're all still going to work just fine. They just might need different ways to access them. Maybe version 1 returns a JSON object, version 2 returns a XML object, version 3 returns a file. Just kind of depends on what you want to do. They all will still work fairly seamlessly and interoperably, as long as we respect their schemes for accessing them. So this is part of the original REST dissertation research, where REST was considered to be kind of a hybrid architecture of various pieces. And we're not going to go through every single one of these little bubbles here. If you want to go that deep, I would honestly recommend pulling up the dissertation or some of the associated papers. But if you kind of follow the lines here, we get some keywords here. So it's programmable, it's layered, it's shared, it's scalable, it's reusable. These are all goals and things that REST strives for. And basically all of these little bubbles are pieces of that puzzle to make it so. So if we start at CS, so here we're at our root, we go down to CS. This is the idea that it's client server. So we have some server, we have some clients. The client's responsible for rendering the user interface. That makes it a bit more portable. The server doesn't have to worry about pushing user interface image to the client. And ideally, then we have this kind of nice separation. So hopefully we improve portability, we improve scalability, separate our concerns, life is good, right? We have a standard client-server architecture here. While we can add on a bit more, we can make it stateless. So the server doesn't care about the state, the client cares about the state. And what this means is that we are basically going to be, having state tracking be pushed off, kind of like what we have with standard servers, right? Made a big deal about every HTTP call being stateless. Same thing is going to apply here. Now, the possibility that this decreases network performance can occur mainly because we have possibly more requests going back and forth. If we need updates, if we need more information, things of that nature, because we have no concept of state. That is possible, but hopefully in this case, it's not a big deal. But if it is a big deal, we can add in caching. So let's go ahead and cache some information. Now, this kind of goes in with the various ways of caching that we talked about before. Let's reduce network load. Let's reduce network latency by kind of getting information from the server, storing it. The client can work on that for a while. And as information gets updated, we need new information, it becomes out of date. Basically, we can do cache refresh, things of that nature. Now, downside here, our cache data might not always be reliable, right? It's possible that it's out of date. The client doesn't know that, but the server has made changes. And then we need to figure out, hey, do we need new data or not? That's a problem for, your individual applications to kind of resolve. So another key point here is that we have a uniform interface. So that's our U bubble. Basically, the idea is that our service implementations are going to be completely decoupled. So basically, anytime we have a service that we need to interact with, we are going to completely separate it out. So any resources that are needed or being sent are being self-described. Any kind of media that's being pushed out is going to be internally represented. And we are going to get to this, we'll get to this next week. Honestly, this hypermedia is an engine of application state. But basically, big long keyword here, all we're saying is that we have the ability to navigate internally. So if you can think of like a relative pathing structure, or I access your service and then I know how to get to some resource via a set of links. So I go to your home, then I go to files, then I go to image.jpg, right? The idea is that we have a navigation structure here. But kind of the key here is that everything is independent, everything is self-describing. All right, so then A couple more to talk about. So we have the idea of layering as well. So this kind of helps to enforce separation of our services. We can, again, we're kind of walling off every service. Everything is going to be self-contained. It's going to be, again, self-described because it only knows of itself and how to talk to the outside world. And the idea here is that we're reducing complexity of our system. Again, you can relate this back to a software engineering concept of having, say, classes or programs be self-contained and focused on one thing and do that one thing really well and provide a public interface to interact with us. Effectively, let's simplify, let's reduce complexity is kind of the goal here. Now, with that idea, okay, it makes sense in pure software, but in a networked application, if we have all these entities all over the place, well, intuitively, you should think that's going to increase network calls, right? Because if I have 500 different services, all self-contained, perfectly described as we see here, I'm going to have to make a network call to every single one of those every single time I need an update. Is that going to improve latency? No, probably not. A lot of extra overhead. We can do caching, we can do lots of optimization tricks in the meantime, but regardless of the networking overhead, this is still a good practice to follow. All right, other things we can do, code on demand. So if you've ever heard of Java applets, like my little Barfy face, or Flash, with my little Barfy face, or I guess Silverlight, or any kind of a plugin where we are bringing in some external feature. Now, hopefully that improves extensibility, but as we're kind of seeing, at least with the evolution of the web, we're getting away from some of these prepackaged, copyrighted frameworks that are out there. Now, bringing in JavaScript applications, modules, things of that nature are kind of taking over in this case. But the idea basically is that this is one way that we could hopefully improve our systems. You could almost think of it now going to the more mobile-oriented approaches first. All right, so with all of this, now let's talk about how we can actually distribute our media. So the entire goal, SOAP or REST notwithstanding, we need to get clients data. We need to give them resources. So the client wants a web page. The client wants a mobile page. The client wants this, client wants that, right? They request a resource, server parses that out and sends it back. Now, in a distributed setup like we've been talking about, we have multiple ways we can handle that. So we could render the data on the server and send the image of this packet back to the client. So whether you consider this to be an image or a packet of data or an application state, it's just this amorphous blob of information. Server packages it up, sends it en masse to the client, good enough. One way to do that. Another way is to actually take the entire rendering engine with that data, send it to the client. And the idea here is that in version 1, we're just sending data. Option 2, we're sending data plus the interface. Version 3, let's send the data to the client with some metadata to describe that, and then the client can pick how they want to render it. So an example there would be, is this the mobile version? Is this the desktop version? Is this a tablet version? Right? So 3 different ways we can handle this. One is more, the client already has a UI, they just need data. Number 2, we're not going to trust the client, and at the expense of extra overhead, we're going to send them more information. The third, let's send them data with how to figure it out. Let the client display it themselves. Multiple ways we could handle that, not necessarily one or the other is, it's more what your situation needs. So if we're going to go the RESTful way, and if we wanted to focus on, in using REST for this type of a situation, we are going to have a shared understanding of the data. So if I'm interacting with your service, I know how the data is going to be represented. I know basically how to access it, how to route to it, that kind of a thing. And I probably have an idea of the metadata to describe that as well, right? This item is the title. This item is an image. This item is the footer, things of that nature. Shared understanding means the client and the server both speak the same language, basically. So basically what we're going to do is we're going to have this shared knowledge. We're going to ideally try to limit what is visible. So we have an interface from the server. I know how to access that, right? I know how to call server.com/get temperature, and that's just going to return a Fahrenheit or a Celsius value. Okay, and I don't know anything beyond that unless I'm a power user. So one way that we could handle this then is let's build up some RESTful components. So we're going to have a user agent, we'll have a server, and then some intermediaries. Now the user agent is going to be our client. So this is a program, this is a user, this is a web page. It's whatever is the thing requesting the resource. Okay, just our client. Our origin server is basically going to be our typical server situation. So still think of it like this is client, this is a server. But in this case, the server is kind of in charge of the routing and all of the resources. So if we're still going with the IoT example, the server is setting get temperature, device ID, edit, update, delete, that kind of thing. So it's in charge of the routing. And then the intermediate components, these are not always necessary, but if we need proxying, if we need to build up public interfaces, or if we want to kind of limit things, basically these are just extra ways of adding extra complexity or extra layers of kind of obfuscation. Depends on what you need, right? Everything we've done so far has been purely client server. We could have, for instance, built a client in a standard web page. We could have built our Rails server, and then we could have put an intermediate program in between that talks to the Rails server and kind of arbitrates these calls for us. Just depends what we need. All right, so then we're nearly done here. 1 second. We'll call this one good. Just wanted to make sure we didn't have a weird break. Be back in the next one, everybody.